Okay, class 11, we had to take now questions on divisibility, proving divisibility questions by principle of mathematical induction. So 19th question there, this expression is given to you, n plus 1, n plus 5. So product of these three numbers expression would be a multiple of 3. So whenever we say a multiple of 3, so multiple of 3 has a factor 3 to it clearly. Okay, तो इसको अगर हमें mathematical statement form में लिखना है, so this is how we write it. This is your statement in words and this is the mathematical form. Pn such that n into n plus 1 into n plus 5 is equal to 3 into something. This can be anything, okay? So multiple of 3, like 12 is a multiple of 3. So 12 can be written as 3 into 4. 18 is a multiple, 3 into 6. 30 is a multiple, 3 into 10. So whatever, 3 into something. Okay, so that is what we are trying to write here. कि अगर ये multiple of 3 है तो इसमें 3 तो आएगा ही आएगा into something, whatever this is. So we are using lambda out here. Okay, any variable can be used. Alright. Alright, so that's our statement. Now again for your first exam we try to check it for very first natural number, that is our 1. So for n is equal to 1, replace n by 1. Here 1, 1 plus 1, 2, then 1 plus 5, 6, so 3, 6 2s are 12 and 12 is 3 4s are 12. So हमारा aim था 3 आ रहा है नहीं आ रहा है. To see multiple of 3 we should have 3 as its factor. So हमें 3 अलग करना है. So yes, 12 में 3 आता है, 3 4s is 12. Okay, so once you've shown that 3 into something, you would say yes, this is a multiple of 3, so P1 is true. Now assuming the result true for any natural number, say k. So in place of n now we have k plus 1, k plus 5 is again 3 into something. To prove for the next following natural number, that is your k plus 1. तो n की जगह अभी k plus 1 आ गया है, तो यहाँ जाएगा k plus 1 plus 1, यहाँ पर आ जाएगा k plus 1 plus 5. Okay. अब the approach for these questions, बाकियों में तो जब हमारा सीक्वेंस चल रही थी, सम ऑफ अ सीक्वेंस, प्रोडक्ट ऑफ अ सीक्वेंस, तो हम वो पूरा रिजल्ट अपना जो given result we had assumed is true, we were replacing that sum or maybe the product of first k terms by its equivalent. Okay, same thing has to be done here. यही result हम utilize करेंगे. The trick will be bit different because यहाँ पे अब ये factor form या expression plus minus में होगा. So what do we need to do is we need to match up with this kind of expression, at least one of something from here, so that it can be replaced. तो आप ये जो expression है इस पूरे को यहाँ आपको ढूंढना है. You need to have a k plus 1 and a k plus 5 so that it can be replaced by 3 lambda. Okay, so अब ये आपके पास in hand था. So from here how to get a k into k plus 1 to k plus 5 is what you have to think. There are so many ways of doing it. I have left it in this product factor form and factor ही बनाए हैं. Another way is अगर किसी को factor बनाने में problem हो रही है, आप इसको पूरा polynomial भी बना सकते हो बेटा. Okay, you can multiply this binomial, ये पूरा एक cubic polynomial आ जाएगा. यहाँ पे भी जो आ रहा है इस पूरे को आप मल्टीप्लाई करो तीनों फैक्टर्स को एंड गेट योर पॉलिनोमियल, एंड उस पॉलिनोमियल से ये जितना ये पॉलिनोमियल मैच होता है उसको रिप्लेस कर दो. ओके, but that's a lengthy process. Little bit more work is required because you'll have to multiply so many all these expressions. Okay, so what I've done is I have formed the factors right out here because I could see k plus 1 here. तो इस k plus 1 को मैंने intact रखा है because that is what was required here. And then यहाँ जो ये k plus 1 है which will actually become k plus 2. Now I am distributing. First I am multiplying this monomial, taking k plus 1 as monomial with k plus 2, and then that I will multiply with the next expression here. Okay, so when I have done that, k plus 1 left as it is and here multiplied with k, so that becomes k into k plus 1. फिर ये 1 plus 1 2 हो गया. 2 will also be multiplied with k plus 1, so this becomes 2k plus 2. Alright, अब ये आ गया product of the first two. Now this whole has to be multiplied to the next one. अब ये next one वाले में भी थोड़ा manipulation हम करेंगे because our aim was to get k into k plus 1. उतना तो आ गया है into k plus 5. So I have rearranged these terms. I have grouped k plus 5 क्योंकि वो मुझे चाहिए था, and 1 I have written separately. Okay, अब ये जो आया था इस पूरे को इस बाइनोमियल में डिस्ट्रीब्यूट करो. सो ये k plus 1 into k plus 5, ये एक्सप्रेशन जो चाहिए था ये आ गया हमारा. देन ऑब्वियसली बट k into k plus 1 also has to be multiplied with 1, so that would give you k square plus k. राइट, अब ये जो रिमेनिंग फैक्टर्स हैं ये भी इस पूरे बाइनोमियल में या रादर इसको भी अब आप सिंप्लीफाई कर दो, योर वर्ड विल बिकम ईजियर. वी कैन राइट दिस एज k + 6 नाउ. वो तो हमें ये फैक्टर चाहिए था इसलिए हमने स्प्लिट करके लिखा था. फॉर फर्दर प्रोडक्ट आप इसको लिख लो 2k मल्टीप्लाइड विथ k + 6. सो दैट विल बिकम 2k into k, that is 2k square, and 2k into 6, 12k. Then this 2 also multiplied with k will give you 2k, and then 2 multiplied with 6 will give you 12. Okay, so that way. अब ये मैनिपुलेशन इज अप टू यू बेटा, हाउ यू वांट टू डू योर कैलकुलेशन. इसको पूरा पॉलिनोमियल बनाओ, हाउ एवर यू फाइंड इट ईजी, दैट यू विल हैव टू सी योर सेल्फ. ओके, सो व्हाट इज द एडवांटेज ऑफ राइटिंग और गेटिंग दिस एक्सप्रेशन. एनी हाउ हमको ये रिजल्ट लाना होता है, बी इट इन प्रोडक्ट फॉर्म, बी इट इन पॉलिनोमियल फॉर्म, विच एवर वे. सो मैंने ये मैच करा लिया था, सो आई विल बी एबल टू रिप्लेस दिस होल बाय इट्स इक्विवेलेंट 3 लैम्डा. जैसे वहां हम बोलते थे बाय ए एंड हम सब्स्टिट्यूट करते थे, लाइकवाइज बाय ए this product will be replaced by 3 lambda 1, and बाकी आप merge कर लो 2k plus 2k square plus k square, 3k square, then k, 12 and 2 together gives you 15k and 12. अब ये आपका maximum simplified form है, but from all these terms 3 is coming common, and that is what our aim was. 3 into something दिखाना था हमने, तो हमने एक 3 common ले लिया, left over आप लिख लो. So whatever 3 into something we have got means this whole expression is also a multiple of 3. That is what we had to show. Okay, so once you show 3 into something, you would say now we started with k plus 1, so this k plus 1 is also, the result is coming true for k plus 1 as well. Hence by principle of mathematical induction it will be true for all natural numbers. See the 21st one now, children. So mathematically we'll write it as Pn x to the power of 2n minus y to the power of 2n is equal to. अब वो divisible बोल रहा था. Now whether I say it is a multiple like in the previous question, or if I say divisible, then this number has to be the factor. Okay, जो factor होगा उसी से वो divisible होगा and उसी का वो multiple होगा. Right? So आप इसको भी उसी फॉर्म में लिखोगे. इसको आपको factor दिखाना था, तो this factor into some scalar, lambda या कुछ भी यूज करो. Okay, now for 1 put n is equal to 1, so this becomes simply x square minus y square. By algebraic identity the factors are x plus y, x minus y. तो x plus y आपका इसमें दिख गया. That is what is our aim. We need to show x plus y as its factor. So therefore P1 is true. Now coming to pk, we will assume pk to be true. So in place of n we've put k here. Again we'll say this is x plus y into some constant, and now we'll show it for k plus 1. तो अब k की जगह यहाँ पे k plus 1 आ जाएगा एक्सप्रेशन में. Now this we'll apply, distribute this inside, so this becomes x to the power of 2k plus 2. Then by law of indices we know if the bases are same the powers are added. तो इसको मैं split करके कैसे लिख सकती हूँ, x to the power of 2k into x to the power of 2. So I've written it as x square into x to the power of 2k. ये जो पावर थी ये split हो गई. Same way here also. So this is y square into y to the power of 2k. Now what we are doing is replacement हमें इसमें भी करना पड़ेगा. Whatever we had assumed true उससे हमें replacement करना होता है. So there are two ways of doing it again. या तो आप ये पूरा expression as it is बनाओ and then replace करो, substitute करो, or maybe change the form here. What I have done here is I am trying to replace x to the power of 2k taking this y to the other side, because that would be easier rather than matching up with this. It will come to the same anyhow. Okay, so x square where it was, and in place of x to the power of 2k we have replaced this by its equivalent from a. So a से lambda x plus y, and this will go to the other side to find x to the power of 2k will come as plus y to the power of 2k. Okay, तो ये पूरा a result से हमने replace कर दिया है, बाकी copy हो जाएगा. Now continue. So x plus y हमें सबसे निकालना है, तो I have kept this x plus y right in front and product of this lambda into x square. Then this x square will also be multiplied with this, so it will become x square y to the power of 2k, and we already have y square y to the power of 2k. So from both these y to the power of 2k comes common, so you are left with x square minus y square, जिसके factors हैं again x plus y, x minus y. So इन सारे terms में से there were two terms here, x plus y आपका common आ जा रहा है. So x plus y into something. So it is divisible by x plus y. If x plus y you have shown as its factor, the whole expression becomes divisible by x plus y. So pk plus 1 is also true shown, will be true for all natural numbers by principle of mathematical induction. Children, same trick continues for the next one. This time this was your expression which was again supposed to be divisible by 8. So it will be of the form 8 into lambda. 1 rakho in place of n. This is what your expression is coming as 2 to the power 3 to the power of 2 plus 2 4, which is 81, and 8 minus 9 minus 8 becomes minus 17. Difference is 64, which is sure a multiple of or maybe divisible by 8. Whether they say multiple or divisible comes to the same. Okay, तो 8 आपने यहाँ पे factor दिखा दिया. P1 is true. Now let us assume this true for any other number. Say R, K रखो, R रखो, any variable you can use. So let PR be true. In place of N now we have R here. This we will assume is true and utilize it further. Now R plus 1 के लिए आपने करना है, तो जहाँ R था वहाँ पे आपने bracket R plus 1 आ गया है. Now this becomes 3 to the power of 2R plus 2. तो 2R plus 2 मैंने क्लब कर दिया है बिकॉज वो यहाँ पर भी था. अब मैं इस पूरे को रिप्लेस करूंगी. दिस होल वी विल रिप्लेस. ओके, सो 3 to the power of 2R plus 2 यहाँ से, एंड ये plus 2 अलग रखा है सो दैट आई कैन राइट इट एज 3 स्क्वायर इनटू फॉर्म, बिकॉज हमें इस पूरे को रिप्लेस करना है. ओके, तो इसको अलग कर देते हैं एज 9. राइट, अब ये रिप्लेस हो गया आपका. दिस होल विल बी रिप्लेस बाय 8 लैम्डा प्लस 9 प्लस 8R. तो वो पूरा रिप्लेसमेंट हमने यहाँ सब्स्टिट्यूट कर दिया है बाय A, एंड रेस्ट विल बी कॉपीड. डिस्ट्रीब्यूट इनसाइड 8 आपने कॉमन निकालने हैं. सो दिस इज 8 इंटू 9 लैम्डा. देन यहाँ से भी आपका 8 आ रहा था, बट ये 8R है और यहाँ पे भी 8R है. सो वी हैड प्लस 9 एंड माइनस 1, सो दैट गिव्स यू 8Rs. 8 हमें कॉमन लेना है इसलिए मल्टीप्लाई नहीं किया. आप चाहो तो 64 लिख लो, मेक्स नो डिफरेंस. देन 9 9s are 81 minus 17, which is 64. So whatever at the end of it, we have managed to get 8 out. We've shown the form 8 into something. Hence PR plus 1 will be true. So for all natural numbers, it is true. Now have a look at this last one also. So that was your statement, divisible by 27. 1, तो 1 रखे easily, it's giving you 27. P1 is true. Now let PR be true. So this statement which we'll utilize for PR plus 1, R की जगह यहाँ पे R plus 1 आ गया आपका दोनों पार्ट्स में. इसको now we know base हम split कर सकते हैं. So we'll write it as 41 into 41 to the power of R. Likewise ये भी 14 to the power of R into 14. Okay, अब इसमें हम इस पूरे को रिप्लेस कर रहे हैं. किसी को भी आप रिप्लेस कर सकते हो. यू कैन रिप्लेस दिस एज वेल, और यू कैन मैनिपुलेट दीज नंबर्स टू गेट दिस एक्सप्रेशन. इट्स अप टू यू, बट दैट कम्स आउट टू बी द शॉर्टेस्ट. सो आई हैव डन इट दिस वे. आई हैव रिप्लेस्ड 41 टू द पावर ऑफ आर हियर बाय इट्स इक्वलेंट 27 लैम्डा प्लस 14 to the power of r by the given statement. Distribute inside. So we've got 27. ये multiply करने की आपको जरूरत नहीं है because your aim is to show 27 out. So we are rearranging and writing it as 27 into 41 lambda. Then this 41 will also be multiplied with 14 to the power of r, and there was already minus 14 into 14 to the power of r. So इसको हम like x या y treat कर सकते हैं. Like terms हो गई हमारे. So we can add subtract them. So plus 41 minus 14, which gives you 27 14 to the power of r's. So बाकी क्या आ रहा है, that is not our interest. The main thing is we've managed to show 27 into something, 27 into some integer, which will prove that 27 is its factor, or it is divisible by 27, or it is a multiple of 27, whichever way we say it.